thanks everyone for joining. Today we have Roger Ford with us. He is the PM for Oracle Text for a long time. Do you want to say something about what you're doing, Roger?
Yeah, I'm the product manager of Oracle Text, and I also step in and help with some of the JSON stuff.
Cool, and this is why he's here, because we're going to talk about JSON performance and indexing. And today we're going to talk about the JSON Search Index. This presentation is also on this short series on performance. So last time we covered a bit about how to store JSON efficiently. So if you happen to watch this as a recording, just to let you know that there is a previous presentation as well, which talks about the storage option. And last time we also covered the functional indexing, and we went a bit into JSON Search Index, which is all of today's topic. So as a recap from last time, we showed that if you know a path expression to a value in your JSON, you can create a functional index on that field. So that would index this value in a B-tree data structure. And for each of these different paths, you would create a different index. Let's say one on ID, maybe one on name. But because the B-tree index relies on the fact that it only extracts one value per row, you run into a problem if you have multiple values per row, which JSON allows you by means of the JSON array. So this is why I came up with a different example here. This is a table I call zoo, and I'm storing JSON as a varchar for 1,000 here, and I'm inserting a couple documents. Those are our animals. So Flipper is a dolphin, and the dolphin likes to eat fish. Our next example is a dog and the cat. So every animal has a name and a species and the food it likes to eat. So the cat likes cat food. And we have a giraffe. The giraffe has no food. We haven't figured out what it eats, or maybe it can eat grass, so we don't have to provide food. And it has an extra field height, maybe height in foot or meters or whatever. And now we have our lion here, and the lion likes to eat also, it likes to eat giraffes, but we don't have that many giraffes, so he has to also eat some cat food from time to time. So that's the sample data we're working with, and I can easily select the values using the simplified syntax. So I'm selecting from my table called zoo. The J call is the column name where the JSON is. And then we go to the name field in one example and to the food in the other. And we see this is now nicely presented in a table. And Flipper likes fish. Mailman has no food. It's a null value. And Leo gets an array here. So we see that we have two values for the food for Leo. So the question is, who eats cat food? The simple way to express this is just to say we extract the value with a path expression $.food and compare it with our meow mix. If we run this query, what we see is only that the cat Findus is found. So we're not finding that Leo also likes or has to eat cat food. And the reason is that JSON value will only extract one value, and because the lion has two values, it's an arrow, and the null on arrow handler kicks in. So for Leo, this JSON value would return null, and obviously the comparison of null with meow mix is not true, so we don't see this row. This can be a bit surprising, but if we use this arrow on arrow clause here, so it's basically the same path expression, but we say if there is an arrow, then raise it. If the field is missing, I think the giraffe had no food, this null on empty, so we would still get a null for that value. Then we see that this query does not get into execution, or it goes into execution, but it aborts. And this fine small font here, we see that JSON value evaluated to a non-scalar value. So that's happening for Leo. So how do we find, before we go into indexing, how do we find that, or how can we compare our meow mix with the values inside an array? And this is what we use JSON exists for. So we're pushing now this comparison into the JSON execution. So what's happening up here, if I highlight this again, we're running JSON value, we extract the value, and this comparison, this happens in SQL. So we have a left side and a right side, and the comparison happens in SQL. And this is why this fails, because we have more than one value. But with predicates inside JSON exist, we're able to push down this filter or this comparison into the JSON execution. So how does this work? So first of all, we don't run a JSON value, we run a JSON exists. And you see that JSON exists returns no value that we're comparing with anything. So this is a Boolean result. We're passing in our JSON, and now there is this very nice, very intuitive syntax how we express what we want to. So this was a joke, it's not very intuitive. So we say, look for a document. This is the dollar, that is path expression dollar, which selects the topmost data or the document it is. And look that this document satisfies a criteria. And the criteria is there is a path relative to the dollar, which is .food, and that must be a string equal to meow mix. So if we run this, we see now that Leo got selected, and the reason is that when we evaluate this JSON exists, if we find food to be an array, so I said earlier it has to be a string, this was incorrect, it can also be an array of strings here. So in the first case, it was a string meow mix. In the second case, it was an array of strings, and we iterated over each of these strings and evaluated this comparison. So if any of them satisfies this filter condition, then the JSON exists predicate evaluates to true. So this equality is more like has exist semantics. So is there a value in the array which is meow mix? So that's the way how we would find the value if there are multiple values. Now the problem is, because of these multiple values, we just can't create a this JSON value index. So if I would create a functional index using this JSON value clause, as we've seen on top, with error on error, this returns our error message. And if we use this JSON value in a create index statement, it would obviously also return the error message. So what we need is something different. We need the search index. So this sounds like a bit of magic, and today we're going to explain it so that you understand how it works, what kind of machinery is running underneath, and how you can best use it. So now we run the same query looking for meow mix. We see the same results got selected, but if we look at the plan here, where's the plan? Auto trace, explain plan. Then we see here, unfortunately, again in a small font, I don't know how to make this font bigger. We see that there is a CTX sys contains in this predicate under a domain index. So this plan now uses the search index, which relies on the context index that you may or not be familiar with in the context of text indexing. This is why Roger is here, so he can answer your questions and correct me if I say something wrong. So this is not a text index. I mean, we have to make this clear that we're not just indexing the JSON as a text and running some sort of text query here. It is still JSON aware or path aware. You can see here, for example, that there is this in path argument. So we're passing some path information to this text domain index. Good. So since this relies on the text index, it also comes with a benefit, meaning that I can do text-like query. So here we use JSON exists with a path expression in our path language, but there is another operator which is called text contains, which allows you to do text-like or full text queries on a field. So here, for example, we're looking for food not being our meow mix, but containing the word mix. So that is an example of an operation that the functional index actually couldn't do. The functional index would allow you to do equality searches or range searches, but it wouldn't allow you to search for a subset of your string here. You could also, I mean, this was in this first example, we were looking in the food field, but we could actually make our query more coarse and just say in the entire document. So this is actually now an example where we could treat the JSON as some sort of a text and look for just a string in any of the values. I think the difference here is that if mixed is used as a field name, it wouldn't show up. So it's making sure that we only search the values, not the key names or part of the structure. And just as a note here, the search index is not limited to just equality or contains, and it's also not limited to just strings. So this is an example where we're looking at a field called height, which is a numeric field, and we want to make sure that the height, if it exists, the numeric value and bigger than 2. So if I run this query, then we see that it also got selected. And to prove that the index was used, we obviously have to do an explain plan, and that shows you that this was actually driven by the index. So I think this is a good introduction on what the index does, and now we're going to what you have to keep in mind when using it. Blaine, is there anything in the chat so far before we should continue, or?
Yeah, so it says, will this JSON exist condition find the string at any depth under the @food, or just as a value of food, the food key itself, either scalar or array?
It's under. So basically here we're looking for mix under $. So if food was an object, it would actually look for mix under this object. Any other questions, Blaine?
Not so far.
Okay, great. Then let's continue here. So one thing you have to keep in mind that the JSON search index relies on some data structures that are maintained. The functional index relies on B trees, and the search index relies on posting lists. So it has internal data structures which capture the information about your document in such a way that it's optimized to finding things easily. And these secondary data structures are synced on commit. So if I do an insert here, let's insert another animal here, our space dog Leica. And now we're looking for this animal. We won't find it. And the question might be here, well, I just inserted it. It's there. This is wrong results. This is incorrect. And a B tree index or a functional index would actually show what you've just inserted inside your transaction. But the search index, as of today, does not. So you have to run a commit here. So part of this commit makes sure that the data structures of your search index are getting updated. And if you rerun the same query again, you see it. Now it's there. Oddly enough, if we delete it, that would be a question for Roger. So if you delete something, even without a commit, it appears to be gone. So it appears to me that only inserts, maybe updates, are not visible within a transaction, but that deletes are visible within a transaction. Can you confirm that, Roger?
Yeah, that's exactly right. Deletes are immediate, okay. Whereas the inserts or updates only take effect once you do the commit.
Right. And this commit, or this sync on commit, how we call it, where these secondary data structures are synced up with your data, that's only the default. I understand that you can also have explicit commits where you call a PL/SQL procedure, or is there also ways to sync every 5 minutes or something like this?
Yes, you can choose between three options. You can have it synchronizing on commit. You can have it synchronizing at a specified time period. So typically that would be every 5 seconds or every 10 seconds or every minute. Or the third option is to do it manually, and you just call a PL SQL procedure.
Right.
There's some reasons you might choose not to do it on commit. It's somewhat more efficient to do it at a specified time interval. It means that there's less chance of lots of inserts or updates interfering with each other if you do it all in one go on a single commit. And similarly, if you do it a longer time interval, then you end up with more compressed index, better quality indexes. So it's always a bit of a trade-off between having stuff ready as soon as you can and having a nice, dense, efficient index.
Right. And better quality index probably means faster queries, right? The results.
It does indeed, yeah. There's an optimization function that you can call to tidy the indexes up to make them more efficient again. But that's probably a little out of scope for the discussion now.
Right. So that's something to keep in mind if you have high ingestion rates and every insert would do a commit, for example, in a, let's say, big data application or Internet of Things application where several devices fire inserts and everyone commit, then that might be an idea to consider to not have the index sync on every individual commit, especially if you're basically just inserting and rarely reading. So let's do the commit anyways. So we've seen that the document is gone. So that was the syncing property. The other thing you need to be aware of is that the JSON Search index indexes your entire document. So this can be great if you have ad hoc queries across the entire document. We've had customers who have to support queries where the path expressions are not really known. So even if the values are all singletons, they couldn't rely on functional indexes because they wouldn't know what path expressions or field names even exist in the JSON data because they're storing data for partners or customers, and these partners are free to change the schema of the JSON, but they expect good query performance. So in this case, the search index is the only option, and the index all is actually a very good property. So after we've created our zoo table and the index, and now if I do a select table name from my user tables, you see that there are 8 more tables which we haven't created. They all start with $, and then there is this IDX1, which was the name of my index. So up here, when I created the index, I called it IDX1. Maybe I should have called animal index anyways. So these are some or all underlying tables that are used to maintain the index, and you can actually select from them, and you see that some of the values we used, like giraffe, giraffes, Lassie, Leo, they're part of this, or they're inside this table, and they are part of this whole machinery. So what I wanted to show you is if I create a view across all, oh, there's a typo, I think. There's always a little glitch in my presentation. And this was it. So I created a view here which does nothing more than summing up the rows of all these internal tables. So we don't have to really understand what they are for. We just have to understand that there is something going on in these tables if we work on the base table. So if I get the actual count, I have 47 rows shared by all these tables, and now I insert an 8th or another animal here, which is Dumbo the elephant, and in addition to the food that our elephant eats, I also have some description. So this may be caused by my application changing. Remember, JSON is schema free or schema less, so as you go, you may decide to capture additional information. And here we have a little description. And if we insert this, we're basically inserting where it appears that we're only doing one insert operation of a varchar2 value. And I commit this to initiate the sync of the index. And now I do a select of my view, which did the count. What was the old value? It was 47. Was that correct? Around this, and now it's 79. So we inserted about 35 or so rows into this. So you see that there is an insert fan out here. You're doing one insert, and the search index underneath has to make changes across this table, and the database actually has to perform a lot more inserts. And I think the same would be true for an update. And if we query this $G table, you actually see that what we inserted, our text here got shredded or got parsed into words, and that these words are inserted in our posting list. So that is just for you to explain why this fanout happens. So something we've seen is that people say, I know what fields I need the index on, and what fields I don't want to index. Unfortunately, we don't have path subsetting yet where you can tell the index what to index and what not. But what we've seen customers doing, and I just wanted to present this idea here, is some sort of manual subsetting. We actually didn't come up with it. One of our customers did. So you can imagine it that you create a smaller version of your JSON, which only holds the values that you want to index. So I called it sub-JSON or sub-JCall. It's also JSON, so I add this JSON check constraint, and I add it as a column to my existing table. And I want to create the subset. So let's say these descriptions here, they could get long. I mean, actually, this is a very good example for a field you would want full text search capabilities on. But in this example here, I might, for whatever reason, decide that I don't want an index on description, but only on, let's say, the name and the food, not on species and height and any other fields. So I have to create a subversion on it. And there's several ways. You could write a PL SQL program, or you could generate it before you insert it. But here I just took this one approach, which is not better or worse than the others, to create a separate object. And I pull out the name and the food out of my zoo column. Sorry, I scrolled. And let's see how this works. So so this is a generation function. We're generating a brand new JSON object. So if we select from this, we could actually see them side by side. If I just make a small change here. Actually, no, it would work, but they're too long. I remove it. So we see, for example, first row, it has name, species, and food. And for the giraffe, we have name, species, and height. And the elephant has the description. But my smaller version of the same JSON would only have the name and the food. So this way, I could create an index whose size is smaller. And consequently, because these long values like the description are not getting indexed, the performance on inserts and update would also be faster. So this is just an idea I'm putting out here, that you can manually do something with path subsetting. So missing value.
And the index will be much smaller as well, which is quite important.
Sorry, say again?
The index will be much smaller as well, which is quite important. Text indexes can get quite large, JSON search indexes. So by using a subset like this, then you're reducing the size considerably.
So I think from development, this is something we should really be looking at and making that easier. But for now, this is something you could do. Now I can, here I'm dropping my larger index, and I'm recreating a second index, the smaller index on this subset of the JSON. And my queries would not really change much. I still have the JSON exist, but now instead of my big JSON, I pass in the small JSON. Remember that these are in the same table. This is just kind of a side column in the same table, so I don't have to do any join here. So if I run this, then I see that my entire document got selected, which has the species and which has the description. So I'm selecting the big document by use of an index scan on the smaller document. So let's just make sure that that was wrong button. I run the entire script, not a problem. I was almost at the end anyways. I think we were here. Yep, it's rerunnable. I just wanted to click at this one here to make sure that the plan shows the domain index, and it does. And you see here in too small a font that it's using the index on sub jcol. That's the only index left anyways, because I dropped the index 1. Now there's obviously a question, and this is how do you keep these in sync? I mean, if you do an update on your bigger JSON, you want the small JSON to be updated, otherwise you will get wrong results. So I can't present like the one best solution. Your application took care of it. You could have a trigger and let the database do it, so a post update or post insert trigger, or you could call this when you do not a sync on commit, but when you explicitly call the sync. Roger had explained that that's an option where you call a PL SQL that invokes syncing the index. Now you could write a wrapper PL SQL, which does not only call syncing the index, but also doing the update on these things where changes have changed, where the data has changed. So this was just a idea.
Comment real quick. It says maybe you can define sub-JSON as a virtual column, so then it will always be synchronized.
Yeah, I had that idea too. I hadn't had time to figure this out. Can I have a text index on a virtual column, Roger?
Good question. I don't think you can at the moment. I think that's something we're looking at for the future.
So whoever asked the question is right, that this should work, but I don't think it does right now. We could give it a try. So when I upload the script to LiveSQL, I will also mention this, and if it works, I add it to the script. So that was my part, a bit shorter. You can ask me any question, or if you have questions unrelated to indexing, that's also fine. We can do this and ask me anything too. There was a question, let me just go by Judith Menzel, and I think, yes, she's also here today. She had asked a question about the search index giving her odd results. Basically, it appeared that JSON value was, if JSON value ran against the index, that it was selecting more rows compared to the index not being present. That is a bug we fixed in the meantime, so I had replied to her, but it appeared we had a little bug in this code. And the main takeaway was that if you know you have multiple values, or if multiple values are possible, you should not use JSON value-based comparison where you compare in SQL. Instead, you should definitely use a path predicate inside JSON exists. So this will always work either by using an index or either by not using an index and evaluating on every row. Versus JSON value might not work if you have multiple values, or it might return odd results because JSON value returns null if you have more than one value by default, unless you specify error on error. And I think what we do now which was the cause of the bug, is that we used to pick up indexes that did not have error on error and null on empty. And that was the bug fix, that we basically have to be a bit more rigid about when using the index or not. But that has been fixed. So Judith, if you need a backport, just shoot me an email and we can initiate getting your patch. So, any more questions?
Not so far.
Not so far. I stopped sharing, now I can look at the chat myself. Oh, sorry, the JSON, sorry, you did mental ask, will this JSON exist condition find the string at any depth? No, it's just at that depth. It's JSON text contains that does a recursive search under food, for example. JSON exist will only look at food either being a scalar or an array of values. This was this exist test that I explained. If let's say food is an object with a bigger nested structure underneath, we would not compare another value than food to use that. Searches are case insensitive. Yes, Gancho. No, case sensitive. They are case sensitive. So uppercase, lowercase matters.
Hang on. Generally not. Most searches are case insensitive. There may be a special case in German.
But we do post-processing, right? I mean, the index is case insensitive, but before we lift it out, we check that the case do matter. So if I go back.
Right.
I think so. Let's go back. I share my screen again. Where is SQL developers here? So let's run this query, meow mix, and make sure it uses the index. What is this?
All right. Okay. It probably is case sensitive for JSON exists, but not JSON text contains.
Yes, that could be correct. Yes. So JSON, I don't know why this shows. Let's go here. Yeah, JSON text contains also allows you to, so this work, I can do the plan. Let's see here. Anyways, we don't, it uses the plan, so if I replace this with IX, it wouldn't return it. Yeah, JSON
Right.
is case sensitive. JSON text contains, let's just run this too. Oh, see, this is now only the index. Remember, I dropped the index. Now let's recreate the index. So we create the index on our base column. This is because we're jumping around in the script. So now this would, yeah, so now this query uses the index. Now let's go back and make this uppercase, because before it wasn't using the index. But still, now it would be using the index, and it's still case sensitive. Whereas text contains needs the index to be present, and if I make this uppercase, then that's correct. Yeah. Text contains, but text contains also allows you to have even text-like operators. So I could have meow near mix. So there are some additional keywords with text semantics that you or that the text team supports and that are also exposed here. Near is one of them. There might be more. I'm not that familiar with it. But I don't think that stemming and synonyms are activated by default on the search index. So there's a lot of options that the underlying text index has. Parts of it is that it knows how that not only words occur in a value, but that they are also close to each other. This is what you can check with near. So if you have a very long text and there are two words, but they're very far away, then they wouldn't be selected. But there's also stemming, where words can have different, I think, plural, or if you look for mix or mixes, it might be the same, and even synonyms. Those are not activated by default, but I think you can, within the realms of this syntax, expose or turn these things on or off. Is that correct, Roger?
Yeah, you can use pretty much any syntax that's available for creating a ordinary text index, a CTX sys.context index,
right?
In the parameters clause of the create search index.
Okay. Yeah, and what I'm showing here is basically the out-of-the-box experience where all you do is, no, where is it? Here, create search index. You give it a name, where to create the index for, and then there is this for JSON. And I think this parameters clause could come after this optionally or something like this, or do you have to?
Yeah.
Yeah. So all I'm showing you here is kind of the default.
So there's another question. What happens with near when the JSON part is food, colon, array, meow, and mix, close array?
I think the answer is going to be that it won't find it, because if they're in separate JSON values, they're not considered to be near each other. The near only counts when they're in the same field. But I'm not 100% certain of that.
And now I copied it over. So what was this again? It was, I see, it was this, right? It was.
So meow and mix are in separate array elements. Yeah.
Oh, what did I do wrong now?
You could drop the table.
No, that's fine. It's fine not to have any garbage in, not have to have duplicates in there. So now we go, we have to create the search index so that text contains even works. And this was the one. Finds it.
Oh, it does. Okay.
But let's say it's cat near meow.
Yeah.
That it shouldn't find that because they are not in the same. Yeah, at least that works.
So they're in the same element, but just an array in that element. Yeah.
Right. Yeah, I mean, is that what you want? Is that what you don't want? I don't know. There could be reasons why you would want to have that row to be selected, but the next question would be how far could they be apart in the array so that near applies. I'm not familiar with like the semantic or the definition of near.
Well, it's 100 words apart by default.
Right. So it would be maybe that translates to 100 array items apart, something like this.
Yeah, could be.
What happens if near is used inside the data as well?
If you want to search for near, you would need to escape it, as it's a special word. You would escape it by putting curly brackets around it.
I see. So if you have a person whose, I don't know, last name is near, then if you were looking for that person, let's say Roger Near, you would have to escape that thing, the near part of it.
Yeah.
Okay, that's something you would have to know if you write like an application with a search box and people put words in there that require escaping. Are there more words that need to be escaped? Is it like a...
There's a set of reserved words which are in the text reference manual.
Great. Yeah.
And I think the JSON reference manual just refers back to that.
Yeah. That's a good question. Maybe I can also add an example for that if I get this on LifeSQL.
Well, yeah, the JSON developer's book contains all the information on this, but it will refer back to the text developer's book in places. So
Right.
If you start with the JSON manual, that should show you where you need to look at the text manual.
Okay.
Another question?
Was there a limitation of remote inserts or remote insert into select on JSON documents? So the data types we use to store JSON is varchar or blob, clob. So anything that works with these data types would also work if the content happens to be JSON. So I'm not sure I understand your question 100%, but my first answer to this would be there's no limitation on remote inserts. You mean like database links? If you mean database links, then yeah, that works.